రికార్డ్ అని యాడ్ కొడతావా? ఓకే. Myself, Dr. G. Venkat Subbarade, Associate Professor of Tribal Department. Today topic is single line diagram and about per unit system. Okay, single line diagram is nothing but single line diagram is a essentials of the system is represented in most simplified form. This power system is normally composed a generating plant, transmission effects and distribution line, and in combination of industrial, commercial, and residential loads. Nowadays all these are in the form of three phase. This is nothing but a simple example of a single line diagram. In case of this is a generator, this is a step up transformer, then transmission line, and again a step down transformer and receiving in this motor. A single line diagram is the essentials of the system is represented in a simplified form in one diagram, that is nothing but a single line diagram. Normally the representation of single line diagram is on the diagram, in the bottom of the diagram all the ratings of the components can be measured. In case of generator 40 MVA 11 kV and subtraction reaction is 20%. In case of motor 30 MVA 11 kV and X dash is 30%, and transformer T1 and transformer T2 our ratings are represented in the bottom of the diagram. That is entire representation of single line diagram. These are the symbols in rotating machine and our 2-winding transformer, 3-winding transformer, fuses, current, potential transformer. These are the symbols representation in case of single line diagram. This is nothing but oil circuit breaker, air blast circuit, delta connection, Y connection, and Y with neutral grounded systems. Next, impedance diagram. In case of single line diagram that can be converted impedance diagram, every component is represented. In case of generator can be represented a constant voltage source behind the proper impedance, and a transformer is represented its equivalent circuit, and a transmission line is represented as a transmission line is nominal pi method. Transmission line is replaced by a nominal pi equivalent circuits, and loads are represented as resistive and inductive series, and neutral grounding impedance are neglected. In case of to convert the single line diagram in case of impedance diagram, then these are the draw the equivalent circuit for a given single line diagram. This is nothing but a equivalent circuit of the given single line diagram. First is generator. Generator can be represented a constant voltage source behind the proper impedance, and the next one is a transformer. Transformer is represented as equivalent circuit, that is nothing but two series component. This is R0 X0 is nothing but shunt components, and the transmission line is represented as a nominal pi method, and the step down transformer is again its equivalent circuits. Loads are assumed to be motor load, that can be resistance and inductives are connected in series. That is nothing but a given impedance diagram of the above single line diagram. To reduce the for simplification, in single line diagram is also represented as a reactance diagram. Then for neglecting the armature winding resistance and series resistance and reactance of the transformer, shunt components of the transmission line, again transformer, this is nothing but a equivalent reactance diagram of the given single line diagram. This is one more example for a one line diagram or a single line diagram. Next. Impedance diagram and its single line diagrams. Next, per unit system. The per unit system is most important. The per unit system is defined as actual value divided by base quantity. The per unit value of any quantity is defined as the ratio of actual value of the quantity to the base value of the quantity in decimal. Per unit system is nothing but the actual value divided by base value. Then per unit systems are dimensionless parameters. Sometimes it is more convenient to represent the value of current and voltage and impedance in per unit values rather than percentage values or original values, because there are advantages. It is a per unit system is unitless on the ratio of the same dimensions. Per unit value is the ratio of actual value divided by base value. Numerator is actual value, base, both are same units. Sometimes per unit quantities ID is mentioned as percentage values by multiplied by 100. Percentage value is equal to per unit value into 100. These are the current, A is equal to actual value base, current, voltage, power, impedance, resistance and reactance are represented in terms of per unit values. Advantages of per unit. The per unit system, by using the per unit system, the calculations are making very simple. To better understanding the problem, major advantages by using the per unit system, the per unit impedance of the transformer is same whether referred to the primary side as well as secondary side. These are the ordinary parameters vary considerable with the variation of physical size, terminal voltage and power rating, etc. While per unit parameter independent of these quantities over a wide range of the sometimes operators. In other words, per unit impedance values for operators is like rating within the narrow range. It provided more meaningful information. The chance of confusion between the line and phase voltages in three-phase balance system is reduced. A per unit phase quantities has the same numerical value as the corresponding per unit line quantities regarding of three-phase connections, whether star or delta connection. The impedances of the machines are specified by the manufacturer in terms of per unit values. The per unit impedance is referred to either side of the single phase transformer. This is a very important advantage. The per unit impedance is referred to either side of the single phase transformer is same. The per unit impedance is referred to either side of three phase transformer is same regardless of the connection, either delta delta or star delta or delta star. The competition effects of power systems is very much reduced within the use of three quantities. Usually per unit quantities being in order of unit or less, easily handled with digital computer. Manual calculations is also simpler. Per unit quantities simply theoretical reduction and give them more generalized forms. In electrical engineering, three basic quantities are voltage, current, and impedance. Among these three quantities, we selected two quantities as a base or reference value. The third one is automatically base or reference value in relation between other two. For example, the voltage and current both are selected as a base quantities. The impedance is also as a base quantities in relation between the voltage and current. The selection of base. How to the selection of base? The ratings of the equipment in power system. Majority of the equipment in power system is normally measured in terms of kVA and operating voltage. For that reason, the two quantities are selected as a base quantities for easy calculations. For that reason, it is convenient and useful. The voltage and kVA ratings are selected as a base quantities. The base voltage of the system are selected in such way that the per unit voltage and current is approximately unity, and the is approximately unity. In case of analysis, how to selection of base MVA, VB is nothing but a base voltage and kVA is nothing but a base kilovolt ampere. These two are selected as a base quantities. Then from these two values, then calculate the base impedance. According to our definition, the per unit voltage is equal to actual voltage divided by base voltage, but base current in terms of kVA rating and voltage, base kVA divided by base voltage into 1000, that is nothing but a base current. Per unit current is equal to actual value of current divided by base current. Then base impedance is equal to base voltage divided by base current. Base voltage is VB. This is nothing but a base current. Then we get the base impedance. The base impedance, that is equal to Z into kVA into 1000 divided by whole square. That is the per unit impedance is equal to the actual value impedance divided by base impedance. This is a per unit impedance. This is the important relation in case of per unit calculations. One more is the change of base. The individual quantity Z per unit volt, kVA volt and V volt. Then common base quantities are new quantities Z per unit new, kVA new and V new. To change a base to the common value, by using this relation, the per unit impedance is directly proportional to MVA rating and inversely proportional to voltage rating. For that reason, Z per unit new is equal to volt, kVA new divided by kVA volt, V volt divided by V new whole square. This is the important relation while calculation of power system analysis, while studying the power system analysis. One more advantage is the per unit impedance of the transformer is same whether referred to the primary side and as well as secondary side. That can be seen here. The per unit impedance of the equipment corresponding its own rating. Z is nothing but a per unit impedance of the equipment. Voltage and current is a base quantities. Then per unit impedance is nothing but actual value divided by base. Z is nothing but actual quantity. V by I is nothing but a base quantity. Actual divided by base. Z into I divided by V. The similar relation is applicable. The per unit impedance of the transformer referred to the primary side, that is nothing but Zp Ip divided by Vp. But Zp is equal to Zs into Vp by V square. Then secondary impedance is transformer secondary impedance. Transform the primary side. Then Zp is equal to Zs into Vp divided by V is equal. The per unit impedance is Z per unit Zp into Vp. That is the per unit impedance of the transformer referred to the primary side. Then Zs is equal to. But one more relation. The volt ampere in the primary side is equal to volt ampere in the secondary side. For that reason, Vp Ip is equal to Vs Is. Then substitute in place of Vs Is Vp Ip, then Zs per unit. And Zp per unit is equal to Zs per unit. That means the impedance of the transformer is same whether referred to the primary side as well as secondary side. This is a great advantage in power system calculations. The selection of base. Base KVA is selected in such way that the sum of the ratings of all the equipment or largest value of the equipment or any arbitrary value. Normally, the base KVA is used on any of these three following. One is the sum of the ratings of the various components of the system. The second one equal to the capacity of the largest unit or any arbitrary value. We selected any one of these three. Then the calculations are same. Important formulas in while solving the per unit system. These are the important. Z per unit is ZMBA divided by VB square, actual value divided by nu, the change of base, the percentage reactance. One more definition is the percentage reactance is equal to the change of percentage drop due to the given voltage, Ix by V into 100. This is one more important relation. Percentage reactance at base KVA is equal to base KVA divided by rated KVA into percentage of reactance or rated KVA. Finally, we will calculate two important calculations: short circuit KVA and short circuit current. Short circuit KVA is equal to base KVA into 100 divided by percentage reactance, and short circuit current is equal to full load current into 100 divided by percentage reactance. This full load current is calculated by using the given MVA and voltage ratings. Sir.